Welcome to VDMIS video training. In this session, you will learn how to assemble and calibrate the sensors in a CMM powered by VDMIS with Renishaw UCC controller. VDMIS has the most advanced integration in the market to the Renishaw UCC I++ controller, with VDMIS providing a user-friendly interface for sensor assembly and calibration, keeping the UCC server software running in the background and minimized. In this training session, we are assuming that this is the first time you have started VDMIS after the installation has been completed, so there is no sensor or calibration sphere defined yet. We start by clicking on the sensor menu, then in the Smart toolbar we click on the button Sensor Assembly. This checkbox will display or hide the probe head in the graphic area. On the lower left window, we have the entire Renishaw probes library. Clicking one time on any component, it will display it in the graphic area, but it will not be selected until we double-click on it. As soon as a component is selected, then VDMIS will display the next list of lower components that could be assembled. Once the sensor configuration is completed, then we can give it a name. Please note the name must be alphanumeric. The new component name will appear in the upper left window. And now we can type the sensor name to be linked to the newly created assembly. Also, the sensor name must be alphanumeric. We click on the button, Create Assembly, to save the new sensor in the sensors database. If this is the sensor we want to use as reference tool, then we click also on the button, Set Assembly for Ref Tool. The sensor assembly has been completed, so we can close the Sensor Manager window. To see the sensors we have created, we need to click on the tab, Coordinates and Sensors, in the Status toolbar. Right now, we have only one parent sensor with angles A equals 0, and B equals 0. So to create other sensors with different angles, we go again to the Sensor toolbar, and click on the button, Create Sensor. Here we have two options. We can create one sensor at a time by assigning the sensor angles using the scroll bar in angle A and B, or type the exact angle we want. Or we can use the Sensors grid. If you hover the mouse above any cell in the grid, the virtual sensor will rotate to that position, and you can see the angle value in the lower left corner of the grid. Sensors grid makes the selection of all sensors extremely easy. In case you want to unselect any sensor selected previously, just click on it again. Once all the sensors needed are selected, just click OK to confirm the selection, so the new sensors will appear in the sensors database. Next step is to define the calibration sphere. To do that, we click right mouse button on the title, Sphere, in the Features database, then we click on the entry, Create New Nominal Sphere. For sphere coordinates we can type any value or even just 0, because those coordinates will be updated once we locate the sphere. For sphere diameter we need to type the exact diameter, then we type the sphere shaft vector. Before starting the calibration, it is recommended to check the measuring parameters to make sure they are the right parameters for the calibration. We recommend 6 mm for approach and retract, 20 mm for search and clear surface. To locate the calibration sphere, we select the reference tool from the sensor database. Then we position the sensor above the calibration sphere, click on the button Calibrate in the sensor toolbar, make sure the fly mode is checked, then click on the button Locate. Now that the calibration sphere has been located, we calibrate all the sensors we have defined already. We select the main sensor, then we click the right mouse button on it, then click the entry, Calibrate all sensors. Now that all sensors have been calibrated, we can start measuring parts. A quick note before ending this training session about the smart way VDMIS interact with the user by providing clear visual feedback regarding the calibration status of sensors. Gray color will indicate that sensors are not calibrated, while black color will indicate calibrated sensors. Additionally, the upper right corner button will display the date and time of the last calibration once the sensors are calibrated. This approach enhances user experience by providing easily understandable feedback on sensor calibration status. Thank you for watching our training session. If you have any question or feedback, please contact us at info@vdmis.com.